Hi everyone, I hope you all are doing good. In the past video, we have discussed about the correlation, the definition of correlation, and different types of correlation, and different methods of measuring these correlations. So, the two of the methods that we have already discussed are scatter diagram and Carl Pearson's correlation coefficient. In scatter diagram, we plot the values of x and y in a graph and we draw a line trying to connect as many points as we can in the graph. So that will give you the slope of a line which decides the type of correlation. Using Carl Pearson's method, we have a formula proposed by Carl Pearson, and using that formula, we find the value of R, which is the coefficient of correlation. So, depending on the value of R, we decide the strength of the relationship. But there is a drawback to Carl Pearson's method. The drawback is that if the variables x and y are in non-linear relationship, that means the correlation exists, but the correlation is of type non-linear. So in that case, it is not going to give you a very effective answer. I'll show you the example where uh, the value of y is definitely correlated to x, but the value of r is showing less. But using the Spearman's coefficient method, we can find the strength of the correlation to be perfect, because in fact, if we take an example like y is equal to x square, and for every value of x, y is going to be the square of that value, right? If I take x as 1, the y is going to be 1. If x as 2, y is going to be 4. So the value of y entirely depends on x. So we expect the correlation to be perfect positive, but that does not happen in case of Carl Pearson's method, because Carl Pearson's method measures the linear correlation the best. The other types it does measure, but the value will be less. The value of the constant will be less. Whereas we expect there is a perfect correlation, because there is no other contributor to the value of y. Value of y is entirely dependent on value of x. So there is perfect correlation, but it is not showing in case of Carl Pearson's method. But using the Spearman's method, we can get a perfect correlation value for it. We can get the constant as 1. So as an example, we can look at this graph. The value of y is increasing based on the value of x. So there is a definite correlation between the both of them, and there is no other contributor to the value of y apart from x. So there is a definite complete correlation between the values of x and y. But using the Pearson's method, we get the correlation constant r to be equal to 0.88. But if we use the Spearman's correlation method, we get a perfect one, which is a fair thing to happen, because there is a perfect correlation between the both of them. So Spearman's correlation method gives us a good measure of correlation even when the relationship is nonlinear, which is not the case in Pearson's method. Pearson's method does not measure the correlation between x and y if they are correlated non-linearly. It does give you a value, but that's not very accurate value. That's not a good representation of the correlation. How we find the coefficient of correlation using the Spearman's method is by ranking the values of x and y. So we take the two series x and y, and if the rank is not given in the problem, then we rank them based on the values that are present in the data set. X and y are as same as in the Carl Pearson's method. We rank them based on their value, and that's why we call it as rank coefficient. So based on the value, we give them respective ranks, and then we calculate the coefficient based on a formula that is proposed by Spearman. There are two possibilities while ranking. If any number repeats in either series x or y, then there is a tie, and when there is no repetition, there is no tie. When there is no repetition, we will use this formula. The symbol, the Greek symbol that we use to represent rank correlation coefficient is rho, and rho is equal to 1 minus 6 sigma d square divided by n cube minus n. Here d is equal to r1 minus r2, where r1 is the rank in the first series and r2 is the rank in the second series. So we will understand what they exactly mean when we have a problem to solve. So we will go through the problems later. And there is a second formula, and in this case there is a tie. So when there is a repetition of ranking because of the repetition of values in the series, we use this formula. Everything is the same as the first formula except for the numerator has been added with another constant called correction factor. Here there is a correction to this correction factor, this formula m1 cube minus m1 divided by 12, and this is m2 cube minus m2 divided by 12 plus it depends on how many repetitions have happened. Let's take an example of x and y, and let's assume that in x series there is 1 1 2 2 2. So there are 5 elements in x series. The elements are 1 1 2 2 2. So you see that there is definitely repetition, so there is bound to be a tie here. So 1 has repeated 2 times, 2 has repeated 3 times. Our value of m1 will be equal to 2 and value of m2 will be 3. Remember, this m1 and m2 are not values themselves, they are the number of repetitions. As and when we solve the problems, you will better understand the meaning of m1 and m2 and how do we calculate correction factors based on them. Remember this, the correction factor is equal to m1 cube minus m1 divided by 12 plus m2 cube minus m2 divided by 12 plus, if there are more number of repetitions, then we will have to keep adding them, and that will give you the correction factor. Once you have the correction factor, apply that value in this formula, add that with the sigma d square and multiply that with 6 and then divide by n cube minus n, and subtract the whole term by 1, and that will give you the constant rho. Just like the correlation coefficient in Carl Pearson's method, the value of the rho is also going to vary from -1 to +1. Let's solve the problems. Let me read out the problem for you. Two judges gave the following ranks to a series of participants in a drama. Examine the relationship between the judgments. So we want to understand how related are these judgments, whether both of them have judged in a similar way, or is one judge more in favor of the contestant than the other judge. To understand that, we will be using the Spearman's correlation coefficient, and in this case the data is not really original data, raw data set. These are ranks. In this case, rank 1 and rank 2 are already given, so you don't need to give the ranks to the data values, and then you calculate d and then you calculate d square, then apply those values in the formula. Sigma d square gives you, it's 32, so 6 into 32 divided by 8 cube. N is 8 because there are 8 data elements here. So 8 cube minus 8, 1 minus 6 sigma d square divided by n cube minus n. That's the formula. When you apply the formula, you will get the value 0.62. So you can say that there is a positive correlation between the judgments from judge A and judge B. So here you need to pay attention to how we are calculating our row here. Row 1, 2, row 2, 3, row 3, 1 are all calculated independently. We will not mix them up because we are trying to understand the correlation between the two variables. Here we have 3 readings. That means we are going to compare whether the judgment from judge A is similar to judge B, or whether judge B is similar to judge C, or whether judge C is similar to judge A. So we are going to make comparisons among these 3 judges. So we have individually calculated the values of rho for judge A, row, which shows the correlation between the first and second judge and second and fourth. So here we have calculated the values of rho, which is the rank correlation coefficient, which represents the correlation between the judge A, B, and B, C, and CA. So the correlation between the judge A and judge B is represented as rho 1, 2. Correlation between B, C is represented as rho 2, 1. Correlation between judge A and judge C is represented as row 1, 3. So we have three different values, and each of those values of row show the correlation between those two judges, judge A and judge B. So we will have three answers here. So looking at this, we can conclude that there is a negative correlation between judge A and judge B, because row 1, 2 is minus 0.212, and there is a negative correlation between judge B and judge C as well. This is row 2, 3, and this is row 1, 3, which is a positive number 0.637. So the judgments from the judge A and judge C are quite alike. So the similar judgment among the three of them is only between judge A and judge B. The similarity is stronger. The stronger similarity between the judges is between the judge A and judge C. So here you can see, as the rank correlation coefficient is positive and comparatively higher between the judge A and C, the pair of judges A and C has the nearest approach to uh, common taste of beauty. So since this is a beauty competition, we can say that judge A and judge C possess same taste in judging. This is the next problem. In this case, we have two variables x and y, and the values are given, and we need to rank them. So here there is no repetition. All the values are unique, so the ranks also will not be repeated. Here you see that the highest value in x is 58. So 58 will get the rank 1. The second highest is 56. So that will get the value 2 for rank. And then the next highest is 54, and that's why we get the value, we rank it as 3. So we rank them according to the values that are present in the series. The same way we also rank y. So since there is no tie here, we can simply apply the formula and we can solve it just like how we did in the last two problems. So we get the value as 0.667, which shows a positive correlation between x and y. All these calculations are just like the earlier problems. There is nothing new here. The only new thing here is we have ranked them ourselves. So if the ranks are not given, you will have to rank them. So since there are no ties, we can use the first formula and get the result. And this result shows that there is a positive correlation between x and y. So we have come to the last problem. The value of x is given and value of y is given. They say calculate Spearman's rank correlation coefficient for the following data. So x and y are given. First of all, like we discussed, we have to rank them according to their values. So since 103 is great, I've given value 1 to that, but there are repetitions here. So when the ranks repeat, what do we do? So I have copied the values of x and y into Excel so that I can show you how do we rank them, because there is a different scenario here. We have repeated values in the series x and y. So in series x, I have sorted them in descending order first of all. For my ease, you will have to do the same. You will have to sort the given values in descending order and keep giving the ranks to them. So I will rank them according to their descending order. Wherever there is a repetition in X series, I have highlighted them and I take their ranks and add them together. So 5 plus 6 is 11, 11 plus 7 is 18. So 18 divided by the number of repetitions, 18 divided by 3. So that will be 6. So I will replace all these values by 6. So the same happens with y as well. So let us do the same for y. We will order them in descending order, and I have given them ranks. Now I have given the ranks from 1 to 10. Now I highlight the repetitions. 800 has repeated 2 times. 700 has repeated 2 times. Okay, that's it. So there is no more repetitions. 800 has repeated 2 times and 700 has repeated 2 times. So what I would do whenever there is a repetition, I will take their respective ranks, add them together, divide by the number of repetitions. So here 1 plus 2 is equal to 3. 3 divided by 2 is 1.5. So I replace both the values by 1.5. And here 4 plus 5, that is 9. 9 divided by 2 will be 4.5. So 4.5 will take the place of their ranks, earlier ranks. You can see that 1.5 has repeated 2 times here, 4.5 has repeated 2 times here. D is calculated in the same fashion how we did it in the earlier problems, and then D square is calculated. Here you need to pay attention to these new terms. M1 is equal to 3. What do I mean by that? M1 is the number of repetitions, not the values. Since 90 has been repeated 3 times, M1 is equal to 3. And in the next series, 700 has repeated 2 times, so M2 is equal to 2. And 800 has repeated 2 times. That's why M3 is equal to 2. So now apply your formula to calculate the correction factor. So this is your correction factor, M1 cube minus M1 divided by 12. Since there are 3 repetitions in the problem, we have taken 3 terms. So correction factor will be calculated and then it will be added. First you calculate the correction factor, add it to the sigma d square, multiply it with 6, and then you calculate the answer. Here your final answer will be minus 0.765, which goes on to show that there exists a negative correlation between x and y. So this is how you calculate Spearman's correlation coefficient, and the most suitable among all these three is the Spearman's method, because Spearman's method gives you a way to calculate the correlation coefficient for all the scenarios, including linear and non-linear data. Carl Pearson's method gives you a good way to calculate correlation coefficient for data variables that are having linear correlation. There are so many challenges that are available on the internet. Please do look for them and try to solve and practice all the problems. I hope you all benefited from the video classes. In case of any doubts, if you need to understand anything, if you need more problems, do let me know. Contact me on WhatsApp or you can also call me. That would be it. Thank you. Take care.